Well, welcome back. I've got a package here from my friend Jeremy up in Canada. His channel is the Weather Wolf. Link in the description. Check out his channel. Jeremy gets some really interesting decks from Japan, models that are largely unknown here or pretty rare. And he's also very well read on those models and has some really interesting insight about the differences between the Japanese models and the American models, or North American models, I should say. So he is working on an Akai, and I know it's Akai. I like to say Akai, or Akai. I heard somebody say that once. I like it. It's a GX-R88, and it got a little bit of what he thinks, what seems to be some shipping damage on the Capstan flywheel. So we've been discussing how to proceed with the repair, and he decided to just ship it down and let me deal with it. I'm sorry about the focus here, I know, but it'll straighten up here in a second. Anyway, so he shipped it down to me, and I am going to repair this for him and film it and then send it back to him. And hopefully he'll have a nice deck when he's done. There we go. Sorry about that. So you can see what's fallen off here. And it really appears to have sheared off, maybe like a drop or something like that, a hard drop. There was a little bit of damage to the coils, actually quite a bit, kind of from what he showed me, likely from jostling around, I would think. But yeah, we need to bond these back together and try to do so concentrically, and then balance the assembly again, because it will be out of balance. You can see on the flywheel the preliminary balancing marks and then the post balancing after adhesion. Now it looks like, I'm not sure, it looks like maybe he sent both Capstans. Maybe he just wants me to check the balance on both of them. Why not, since you're shipping something? And let's see here. Let's see what he's got. Maybe it's a mini bottle of fine Canadian whiskey. No, it's another Capstan. Darn. Yeah, so that one's intact, and yeah, I think he just maybe wants me to check the balance on that too. So we'll do that too. Okay, so taking a look at this, it really appears that this is 100% adhesive failure. There seems to be adhesive on both components, call those adherents, and a very clean shear type break between the two. So that is a failure of adhesive, not of bonding to the either aluminum or the steel components. Generally on these things, I see the bond failure on one or the other component, and it's generally the aluminum. or aluminum, I should say, aluminum. But see, it's there and it's well bonded. But it's a clean break. And we talked about a lot of times on this sort of thing, you can, it's like a jigsaw puzzle. You can put it back together and find exactly the position that it was in and rebond it. But on this, there's no such jigsaw. It's just it's a clean shear off. So there was really no way for him to get these two parts concentric again. And my plan is to 3D print a form to hold them together in concentricity while the adhesive sets. And Steve, if you're watching, thank you once again for the wonderful gift of these just amazing pencils that I love using every day in the shop and all over. I've got them in the house. It's a joy when you love picking up a writing instrument and just get pleasure from using it. So thank you so much for that. I really appreciate it. All right, so let's take a few measurements and make us up a little form. Just make sure that's clean. Looks like I've picked up a little hitchhiker there. That's not going to help. Alrighty, looks like what we have here is 1 inch 832 and 2, maybe 3. Let's call that 3/10. 1 inch 832 and 3/10. Just give that a double check. These are machined, they should be pretty round. Yeah, that's a good number on that. Now, I don't expect that kind of consistency on this stamped flange. However, it's pretty consistent. Yeah, that's not bad at all. So on this one, I'm looking at 1 inch 733. And I'm going to call that 7/10. 1 inch 33 and 1 inch 733 and 7/10. And I got to say, it's looking very consistent. Not bad for stamping at all. Okay, so now what I need to do is make a form that will hold things in concentricity, hold the two components in concentricity while the adhesive sets up. I'll just do a quick drawing here, write down some dimensions. And just kind of on the fly make the corrections that I want to make for clearance. And since this will be a 3D printed model, for some compensation that I'm aware happens when I 3D print things. Okay, so there's my model. Very simple thing. And then I'll just add a little bit of draft right here on the ID bore. I think it was 1.3 degrees for anybody keeping score. And then I'll just randomize the seams on the 3D print. That'll help center everything a little bit better. Okay, so here's my first form. That red on there is not for any purpose. It's just because that's the filament I had in the printer, and then it ran out and I had to swap them. So there's nothing going on there at all. That is super tight, way too tight. Not what I expected at all. So that fits perfectly. Why is the other so tight? Yeah, that's not even usable. That shouldn't have been that way. Now some of you probably caught it when I wrote down the measurements, but I'm still in denial about it. Or not wrote down the measurement, but transferred the measurement onto the sketch. Yeah, my number's solid. But what I did there is I wrote down, excuse me, I wrote down 832, and down here I wrote down 820. Well, basically 822, but I rounded up to 824. So I made a error there. Okay, so here's the second print. Peel the brim off. This one should fit much better. This little centering fixture could have obviously been made out of any number of materials. 3D printing is just so fast for something like this, and it's adequately accurate. And, it works well because it can be printing while I'm doing something else. This one took about 12 to 13 minutes to print, and a lot of that time is just heating up nozzles and beds and so forth. That fits much better. Okay, I like that. I'll try to get this old adhesive off. It's not 100% necessary, but I don't know what it is. I don't know what that adhesive is. And so I don't know if what I will put on it will bond to this adhesive. So I need to clean it. If I knew it was epoxy, I knew it was, one thing or another thing, then I could have an idea whether or not my new adhesive would bond to the old adhesive. But in this case, I don't. And so the safe thing to do is just get it off. Now y'all probably know that the solvent for epoxy is acetone. And so I'll try some acetone on here and see if that starts to dissolve it. Yeah, it looks like it is. It's starting to get sticky, and yep. So I'll just have to spend a few minutes with this. And we should be down to base metal. Yeah, that seems to be coming off there. Probably soak this for a few minutes and don't want to take any abrasives to this because it looks like this is zinc coated, and hopefully the aluminum is anodized. So I want to leave all that on there. People probably know this, but bonding to aluminum, bare aluminum, doesn't work. It works temporarily. It works for a few minutes. Maybe you might get 4 or 5 years out of it if it's not under any stress. But it needs, at very least, an iodine coating, or the best option is mil-spec adherent coating. And that's what we have to do here in the shop on that material. Yeah, that's actually coming off of there nicely. But that's confirmed. That is 100% bond failure. Which is unusual. Again, it's not something I see a lot of. I usually see it fall off of one side or the other. Yeah, we'll just quickly clean this belt debris off too while I'm here with a soap drag. When I go to balance these, of course, I don't want to have any belt debris or anything else on there that will affect that. So we'll clean this up as well as I can. Okay, so I've got all those cleaned up and ready for bonding. And check my fit. Fit is exactly the way I wanted it to be. Perfect. Couldn't be better. I've got some paraffin wax here that I'll use as a release agent. I'll just coat the inside of the mold or the form with that wax in case a little bit of the epoxy squeezes out. It's make it easier to take apart, and then I won't have to cut it apart like a cast, hopefully. Just kind of rub it in there and then wipe off the excess, blow it off, and I've got a good release agent. Now clean my hands up as well. Okay, we are ready to bond. I'll be using the same epoxy I used on the last job. This is a structural adhesive. I think I have talked about it before, how the 5-minute epoxies are not suitable for anything that needs to last for any amount of time. They are hygroscopic, and they will pull moisture vapor from the air that will both cause corrosion on the adherents, and it will break down the epoxy itself. So kind of a rule of thumb on the consumer epoxies like we find at Ace Hardware, that sort of thing, the more time required for setup, the stronger the bond will be. So a 2-hour set time will have a higher bond strength than a 5-minute set time epoxy. A 12 or 24-hour set time epoxy will have a higher strength characteristic than the 5-minute or the 1 hour or the 2 hour. And that's just kind of a general rule for consumer epoxies. When we're talking about aerospace, medical, industrial stuff, there are fast set adhesives that do have equal properties, but they are extremely expensive. They have very short shelf life times, and they're not commonly available to us. So for the types of things that we pick up in the store, the slower they set, the stronger they'll be. And I also have a habit of very thoroughly mixing things up. A good minute or two spent doing that part of it. I'll just snug that up and do it in here. And a little bit of excess acetone in there. We'll dry that out and then re-clean the bond faces again. Dry that off. This particular adhesive requires about 24 hours cure time, and it is structural, and it can be speeded up, but my shop conditions here aren't bad. 60, maybe 60 degrees, I'll just put a ring around it, try to kind of keep it balanced as much as possible. And then I will definitely get a little bit of adhesive in those casting crevices. It's like a little, acts as a bit of a lock, like a dovetail almost. I'd really rather have too little than too much, but I just want to get some on there and then even it out much more than the factory used. Yeah, I didn't really plan this, but it looks kind of like a little smiley face there with a I don't know, maybe bangs hair, I don't know. Yeah, that's it. Just a perfect fit. Yeah, I really like that. It doesn't need much clamping force, but it should have some. All right, we'll let that sit for, we'll let it sit overnight and take a look at it. I always leave the excess epoxy in the same area so I can test it for, make sure it's been, make sure it's set up, and then come back the next day and hopefully this mold will release and I won't have to cut it off. Let's see what happens. Yeah, that's on there pretty good. There it goes. Excellent.
Excellent.
Okay, a little bit of squeeze out, not bad. I'm very okay with that. Right now this is probably 70 or 80% cured, so I can still scrape that excess, that squeeze out without it being completely hard and causing me more problems. Just take a little dental pick and just clean that little tiny bit out there. That wasn't bad at all. So obviously every bit of this affects the balance. I like to do a clean job on it, but that excess epoxy on one side and not on the other will actually affect the balance. So okay, very good. The idea of that's cleaned out. The bore, need to get some measurements on that bore so that I can make the plug and extend out the extension plug to extend out the capstan on the other side for the balancing stand. So I got to make sure that's clean. I need to measure diameter and depth. And I want to be pretty accurate with this. So I'm looking for very good concentricity. I'm just kind of sketching out the part I need to make or 3D print. Now I've got several different ways of determining this bore. Ideally, I would have had a plug gauge, but my plug gauges end at 3/4, and this is larger than 3/4, 0.750. And so I'll need to do it a different way. So use a telescoping gauge. Put my eyes on so I can read this. I'm getting 778. And on this one, that's going to be 7/10. So I'm getting 778 and 7/10 on this one. This mic reads a little differently than the others do. It's got 0.5 hash marks. They're thought to be a little bit more accurate. Or repeatable. They're thought to be more repeatable, and I believe that they are. Okay, that checks out there. I want to see if I've got any high spots or particularly low spots I need to be aware of. Okay, it seems pretty accurate. I've got a tri-mic here to also confirm my telescoping gauge. I typically, on telescoping gauges, because I've got a light touch. Some machinists have a heavy touch. I have more of a light touch. I'm dealing with typically smaller components. And so I typically find my telescoping gauge measurements are a little bit heavy of what the actual numbers are. So I like to double check things. I'm sorry, I should say light. My telescoping gauge measurements are generally a little bit light of what the actual number is. And that's, like I say, because I have a pretty light touch with them. So this measures in 3 points instead of 2. There are a lot of ways to measure bores. Bores are difficult to measure, especially when you're measuring just a point contact like these are. But this is a fairly good way to do it in the absence of air gauges. And this is shockingly exactly the same number I got with the telescoping gauge. that almost never happens to me. So if you look at this and read it, that is right in between the 6 and the 8 10,000ths mark. That puts it at 7. And if I did this 10 times, I would not get the same number again. It's only because I turned the camera on that it worked. I actually wanted to try and show how different instruments will measure slightly differently in, real life situations. But because I turned the camera on, this one measured identical. All right. Once again, sorry for the focus. I'm not really paying attention to the camera like I should be today. So I'm just sketching out what I want to model up and print. And again, I want to introduce a little bit of draft so I can push that. This will have draft on its own because it was cast, and I don't know how much draft is in there, but I want to introduce my own for my purposes, not because I'm casting anything. So I've got I'm reading about 705 thousandths on the depth, and I got a pretty good radius down there. I don't need to go to the bottom. I think I'll just make this maybe 625, 5/8. See how that looks. Yeah, we'll just make that 625 deep. So there's my model for the plug. I've got it printed and in the lathe now, and I've got a pin gauge in the bore. Obviously on the 3D print, it's not going to be perfect, so I'm going to bore, get it centered, get it concentric, and then bore to size on where the extension will come out. Again, to get myself as concentric as I possibly can. So this is a 55 thousandths solid carbide boring bar. I think they call it a twist. It's a micro 100. These are my favorite solid carbide boring bars, except for the ones my buddy builds me. These are just exceptionally well made and rigid when you get to these small numbers. So what's 55 thousandths? That's going to be less than 1.5 millimeter. The capstan on this measured 90.5 thousandths. And so I'm shooting for somewhere in that range. It doesn't have to be perfect, but I just need a number that I can capture and then turn the extension shaft to that number. That's all I'm doing here. But I want it concentric. I want it concentric to the OD. So I'm just using pin gauges here to determine what my size is, my bore size. Okay, getting close there. Too big there. Right in between. Right there. So that was a little bit loose. I want to take it up to the next size. And I'll just make a spring pass on this. Let's see if I can get it out, get the right feel to the next size pin gauge. Maybe one more. I don't have a lot of experience. This is just a PLA. I don't have a lot of experience turning PLA, so I don't really know what to expect. I'm taking some material off there, so it should be good. Yep, that's the fit I want. Just confirm it's concentric. Okay, now I need to turn a stub arbor or stub post for the to simulate the counter capstan, the opposite side of the capstan shaft. And I've got some 7075 aluminum chucked in here, not for any reason, it was just handy to me. So now, of course, I want to make this shaft the exact same size as the pin that fit the way I wanted it to. And I'm about half a thousandth over here, so I could possibly just polish this. Let's see. I don't want to take much off, but let's see what that does. Yeah, that only took about 2 to 3/10 off, so again, just another spring pass. That's a couple tenths over. Now that'll just polish out. Okay, that's right where I want it. That's about a tenth over, and that's fine. I'll finish it out here. Good. Square up the face. We'll give it a little chamfer to compensate for my interior chamfer. Part it off, and there's my stub arbor. Yeah, I just want a clean everything off of this. Pop it in there. And tappy tap tap. Okay, let's just make sure it's seated. Okay, let's see how close to balanced this is. I don't expect much. Find a piece of non-magnetic. There we go. Okay, well, there's some pretty obvious heavy spots here. No question about that. I'm also looking, while I'm doing this, at the far end of the actual capstan shaft, just to kind of try to judge by eye its run out and see that, I've done my job well. Okay, so I did most of this off camera. I've done other videos of that. Maybe I can stick a card up here somewhere. But I don't think this makes particularly good video. So I'm just going to fast forward through this and not torture you guys with it like I have in the past. So depending on how good or bad these are, this process takes me anywhere from 30 to, 45, 55 minutes, an hour. I think I probably tend to get these more close than they maybe need to be, but I don't know. I have one level of quality. I don't have different levels of quality for different jobs. I kind of just do everything the same way. So if it's within my ability to make it better, I'll keep working on it until it gets better. Now I'm actually using a couple of the existing balance marks on this. And so, it makes me feel like I got things centered really well. as I keep going on it, there's a couple on the interior that are in exactly the right place that I need. And so I end up relieving more material from two of the factory balancing marks to finally dial it in. Getting really close to it now. So that's a factory mark. The one to the left of it is a factory mark, and then those two that look like they're brand new are brand new. Those are mine. Right there. And that was the heavy spot. So you can see it's no longer gravitating towards that. At this point, I'm pretty much done working on those, and then I'm using the factory marks on the other side of this flywheel, on the what would be the outboard side. And I just keep working on those little by little. And obviously what I want to do is be able to put it in any spot and have it remain in that spot. And I don't break these up into 4 or 8 quadrants. I just randomly work on it. This is the other one that he included. And I want to just check the balance on it. And I'll fast forward this one as well. You can see all the factory balancing marks there. I think there's, what, 4 or 5? This one was not as far out, but it's still a little bit out. And again, on this one here, I'm working on the factory balancing marks on the inside right there. You can see them, and I'm taking a little bit of material off of those, and I'm just deepening those up a little bit. So again, I feel like my setup is I'm replicating what was done before, so I don't feel like I'm too far out of concentric. Now what I want to point out right here is that balancing mark right there that was done before the boring. So just pointing out how this was a 2-part balancing job, before and after adding components. Okay, I think I've got this one dialed in pretty well. Okay, I'm happy. I hope that works for you, Jeremy. I'll pull these plugs out. These are completely sacrificial parts here. They go into the waste bin after the job's done. Now that's not pulling out. That was a really tight fit, so I'll drill a hole and then run a screw in there and see if that will just bottom out and pull it out. Now that one just stripped. Maybe I'll just do this and then pull on it and see if that'll come out. Okay, so that's what I have for you today. This job gets checked off the list. And Jeremy, I hope this gets your Akai back on its feet. And I will look forward to watching the video of you getting that done. So thank you everybody for watching, and I'll see you back here soon.